Today we are going through types of matrices. So in this section we discuss certain types of matrices based on their order and elements. So first one is column matrix. Column matrix. Column matrix is a matrix having only one column. A matrix having only one column is called column matrix. So for example, matrix A is equal to x 0 minus 1. Here see the matrix A is a column matrix of order 3 rows, right? There are 3 rows. A has 3 rows and 1 column. So it is a matrix of order 3 by 1. And another example, B is equal to 2 minus 8. It is also a column matrix of order 2 by 1. There are 2 rows and only 1 column. So it's a column matrix of order 2 by 1. One more example. Matrix minus 5. So it's also a column matrix of order 1 by 1 because there is only one column and one row. One row and one column. So matrix minus 5. The matrix C is a matrix of order 1 by 1 and it is a column matrix. So next matrix is row matrix. Row matrix is a matrix having only one row. A matrix having only one row is called row matrix. Example, that A is equal to a matrix minus 5, minus 1, 1. Say, it's a row matrix of order 1 by 3. There are 3 columns. Okay, only one row and 3 columns. So it is A is a matrix, A is a row matrix of order 1 by 3. Another example, sin x, tan x. See, it's also a row matrix of order 1 by 2. There are 2 columns, only 1 row. So B is a matrix, B is a row matrix of order 1 by 2. Let's take one more example. C is equal to matrix 8. Okay. See, it has only one row and only one column. So we can say it's a row matrix of order 1 by 1. So therefore, the matrix of order 1 by 1 is both a row matrix, column matrix and row matrix. Next matrix is square matrix. So according to its name, it must be a square, right? So here, now let us see what is a square matrix. Square matrix is a matrix. A matrix is said to be square matrix if number of rows is equal to number of columns. Okay, so if a matrix in which number of rows is equal to number of columns, this matrix is called square matrix. For example, matrix A is equal to here 1, 5, minus 3, 0, 1, 2 minus 5, 6, root 3. Root 3. See here, matrix A has 3 columns, okay, 3 rows. Here number of rows is equal to number of columns. So the matrix A is called a square matrix of order 3 by 3. Or we can say here number of rows and number of columns are equal. So we can say it's a matrix, square matrix. Okay, A is a square matrix of order 3. That's all. A is a square matrix of order 3. Okay, another example. B is equal to sin x minus cos x, sin x. Okay, so here see B has 2 columns, 2 rows, right? 2 rows and 2 columns. Number of rows is equal to number of columns. Therefore, B is a square matrix of order 2 by 2, or we can say B is a matrix of order 2. B is because it's a square matrix, its number of rows and number of columns are equal, right? Therefore, B is a square matrix of order 2. One more example. C is equal to see here, there is only one element in this matrix. So, it is also a square matrix because here only one row and only one column. Okay. Therefore, C is also a square matrix of order 1 by 1, that is 1. Okay. So, we can say C is a matrix, square matrix of order 1. Okay. A is a square matrix of order 3. B is a square matrix of order 2. And C is a square matrix of order 1. Okay. And here these elements 1, 1, root 3. Okay. These elements are called diagonal elements. Diagonal elements of square matrix. Okay. Diagonal, main diagonal. It is the main diagonal of the matrix. See here 1, 1 and root 3 are main diagonal elements of the matrix A. Next is diagonal matrix. Diagonal matrix is a square matrix in which all its non-diagonal elements are 0. Okay. Diagonal matrix is a square matrix. Remember, diagonal matrix is a square matrix in which all its non-diagonal elements are 0. Okay, all its non-diagonal elements are 0. In other way, that is, let us take a matrix A is equal to Aij. See, matrix Aij means Aij are all the elements of the matrix A. Okay, here suppose it is a matrix of order n by n. Is a diagonal matrix. It's a diagonal matrix if Aij is equal to 0 for I not equal to j. See, when I not equal to j, if I is equal to j means all the elements are diagonal elements. Say I will write a 3 by 3 matrix, square matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. See, we observe that all the diagonal elements here I and j are equal, right? That is A11, A22, A33. So here in scalar matrix, all non-diagonal elements except these elements, non-diagonal elements must be 0. Okay, that matrix is called diagonal matrix. Let us take one example. See, it is Aij, that is, if A is equal to matrix Aij, is a diagonal matrix. If Aij means every element of a matrix is equal to 0 when only for I not equal to j. Okay, not I is equal to j. When I is equal to j means these are diagonal elements. So for I not equal to j. Okay. See, in these elements I not equal to j. 2 1 I not equal to j. 3 1 3 2 1 2 1 3 2 3. Okay. I is equal to j means these are diagonal elements. So except I not equal to j. Okay. For I not equal to j, aij is equal to 0. Okay. So aij is equal to 0 for I not equal to j. Let us take one example. You will understand it quickly. A is equal to, okay, now let us take 2 by 2 matrix. Okay, a square matrix 5 0 0 2. See, it's a square matrix and it is a diagonal matrix also, because see, these are the main diagonal elements. So except these elements, non-diagonal elements are 0. Okay, except these elements, other elements are 0. Therefore, matrix A is a scalar, diagonal matrix of order 2. Okay, now let us take 3 by 3 matrix. Matrix 8 0 0 0 minus 1 0 0 0 1. See, look at this example. Here, see, these are the main diagonal elements. Okay, 8 minus 1 1 are diagonal elements. So except these elements, okay, except diagonal elements, all non-diagonal elements are 0. So matrix B is called, B is the diagonal matrix of order 3. Okay. Here, what is a diagonal matrix? It's a square matrix in which all its non-diagonal elements are 0. Here, see, diagonal elements means, see, it is the main diagonal elements. Okay, here diagonal elements means only these are the diagonal elements, not these one. Okay, only these are the main diagonal elements. So it is the definition. So if A is equal to Aij is a diagonal matrix if Aij is equal to 0 for I not equal to j. So these are the examples. So here we can take one more example. Scalar matrix. Next one is scalar matrix. See, it's also a square matrix. Scalar matrix is a square matrix in which all diagonal elements are same and non-diagonal elements are 0. Okay. Scalar matrix is a square matrix in which all diagonal elements are 0 and non-diagonal elements are diagonal elements are same, okay, and non-diagonal elements are 0. That is, here we can write, let A is equal to Aij, a square matrix. Let us take, it's a square matrix of order n. Then is a scalar matrix. It's a scalar matrix if Aij is equal to okay, let us take one constant alpha. Okay, alpha is a constant if I is equal to j, when I is equal to j, and 0 if I not equal to j. Okay, see, in this way we can define. Here Aij means all the elements of this square matrix. So here it is scalar matrix if Aij is equal to a constant number. Okay, a constant if I is equal to j, means I is equal to j means all the diagonal elements. If Aij is equal to 0, if I not equal to j, I not equal to j means non-diagonal elements. Okay, so here, see, for example, let us take one example. Matrix A is equal to 5, okay, 0, 0, 0, 5, 0, 0, 0, 5. See here, you just compare this. See, you will understand. You will understand it quickly how we defined this scalar matrix. Okay. See here. Here all the diagonal elements are same. Okay. All the diagonal elements means here I must be j, right? So if I is equal to j, aij is equal to alpha. That is a constant. Okay, a constant number. So here aij is equal to 0 if I not equal to j means all non-diagonal elements are 0. See here, these are the diagonal elements. So except these elements are 0. Okay. So here it is the matrix A is the scalar matrix of order 3. So remember what is a scalar matrix? It's a square matrix in which all the diagonal elements are same and non-diagonal elements are 0. Okay. Next one is identity matrix. See, it's also a square matrix and it is similar to scalar matrix, but here see the identity. So the elements must be 1. Which elements? The diagonal elements are 1. Okay. So here identity matrix is a square matrix in which all diagonal elements are 1. Okay. And non-diagonal elements are 0. All its diagonal elements are 1 and non-diagonal elements are 0. Okay. That is, here we can define A is equal to matrix Aij of order n is an identity matrix. Is an identity matrix if Aij is equal to, here first let us write diagonal elements. Okay, Aij is equal to 1. Okay, all the diagonal elements are 1. If I is equal to j, then diagonal elements, when I is equal to j means all the diagonal elements. Okay, it represents diagonal elements. And Aij is equal to 0 if I not equal to j. Okay, that is all its diagonal elements are 1 and non-diagonal elements are 0. For example, A is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Here main diagonal elements are 1 and non-diagonal elements are 0. Therefore, the matrix A is an identity matrix of order 3. 1, 0, 0, 1. See, here also main diagonal elements are 1 and non-diagonal remaining elements are 0. Okay, so the matrix B is an identity matrix of order 2 and C is equal to matrix 1. There is only one element, that is 1. So this matrix is an identity matrix of order 1. Next one is zero matrix. See, zero matrix is nothing but it's a matrix. Okay, maybe square or any other matrix. Okay, it's a matrix in which all elements are 0. That such a type of matrix is called zero matrix. Okay, for example, 0, 0, 0, 0, 0, 0. See, it's a matrix. A is a matrix. A is a zero matrix of order 2 by 3. Okay, of order 2 by 3. Or B is equal to 0, 0, 0, 0. B is a zero matrix of order 2, 2 by 2. Okay. So next, let us go through equality of matrices. See, what is equality of matrices? See, two matrices A and B are said to be equal matrices if their corresponding elements must be equal. Okay. if two matrices are said to be equal matrices if their corresponding elements must be equal. For example, let us take A is equal to root 5 minus 3, 8, 7, root 2 minus 1. Okay. B is equal to root 5 minus 3, 8, 7, root 2 minus 1. See here, A and B are equal matrices. Why? Their corresponding elements are equal, right? Root 5 minus 3, 8, root 5 minus 3, 8, 7, root 2 minus 1, 7, root 2 minus 1. So here we say A and B are equal matrices. Now let us go through an example. Find the values of x, y and z from the following equations. See, these are the two matrices. Matrix 4, 3, x, 5 is equal to y, z, matrix y, z, 1, 5. We know that if two matrices are equal, then their corresponding elements are equal, right? Therefore, here the 4 corresponding element in this matrix is nothing but y. Okay. Therefore, if two, here it is given that these two matrices are equal, therefore their corresponding elements are equal, right? So 4 is equal to y. So we can say 4 is equal to y. Since these matrices are equal, 4 is equal to y. Okay. So y is equal to 4. Then z is equal to 3. Then x is equal to 1. Its corresponding element is 1. So x is equal to 1. So x is equal to 1, y is equal to 4, z is equal to 3. Look at next example. Find the values of A, B, C and D from the equation two matrices A minus B, 2A plus C, 2A minus B, 3C plus D is equal to minus 1, 5, 0, 13. Here, given that two matrices are equal, then we have to find the unknown values, that is find the values of A, B, C and D. And we know that if two matrices are equal, then their corresponding elements are equal, right? So here we can write some equations, that is corresponding element A minus B, that is equal to minus 1. Equate A minus B is equal to minus 1. Okay, take it as first equation. Then 2A plus C, its corresponding element is 5. 2A plus C is equal to 5, because here these two matrices, since these two matrices are equal, their corresponding elements are equal. Okay, so 2A plus C is equal to 5. Take it as second equation. 2A minus B is equal to 0. Third equation. 3C plus D is equal to 13. That is fourth equation. Okay. Now here let us consider first and third equation. Equation third minus first one. This gives, see here, because its coefficient is 1, right? Okay. So let us subtract these equations. What we will get? 2A minus A, that is A, is equal to minus B. See here, B is cancelled, right? Minus B minus minus B. So minus B plus B, B is cancelled. That is equal to 0 minus minus 1. Okay, so A is equal to 0 minus minus 1, that is plus 1. Next, see here we have got A value. So substitute A value in the first equation so that you will get B value. Okay, so A is equal to 1. So first equation gives 1 minus B is equal to minus 1. That implies, take 1 here. So minus B is equal to minus 1, minus 1. So minus 2, that implies B is equal to 2. Okay. So here we have got two values, that is A is equal to 1 and B is equal to 2. Then next we have to find the C and D values. So here for finding C values, see, consider the equation 2. Equation 2, because we have value of A, right? So substitute value of A, 2A, that is 2 into 1 plus C is equal to 5. That implies 2 plus C is equal to 5. This implies C is equal to take 2 right side. So 5 minus 2, that is 3. So here we have got value of C. Then next we have to find the value of D. Consider equation 4. So equation 4 implies 3 into C, the 3 into 3 plus D is equal to 13. This implies, here it is 9 plus D is equal to 13. Take 9 right side. So D is equal to 13 minus 9, that is 4. Okay. So D is equal to 4. So the values of A, B, C and D are A is equal to 1, B is equal to 2, C is equal to 3 and D is equal to 4.